In this video tutorial, what I'm going to be looking at is how do you rationalize cube roots. All right, so let us say that I'm working on the problem and my final response is 3 over the third root of 5. How do I rationalize this? The act of rationalization is to ensure that we do not have a radical in our denominator. So when I'm done working, I do not want to have a radical as a denominator. So how do I get rid of this? Firstly, we have to think about what we're dealing with, right? So in this case, I'm dealing with the cube roots, right? So I'm going to have to think, right? What do I need to cancel, right? The cube. So take a look. I'm going to have to multiply the numerator and the denominator with a specific idea such that when I merge them, I'm not going to have a radical at my denominator anymore. Remember, though, that this 5 is just 5 raised to the first power. If I put 5 to the first power here, it's not going to give me what I want, right? That I'm going to put this 5, I'm going to have to raise it to the second power. And by saying this, the law of the radicals suggests that if we multiply the radicals, then this and this would actually multiply. So that's the law. One of the laws of the radicals suggests that we can multiply the radicands. So this is going to produce this. So imagine that we have this. Take a look at what's going to happen at the bottom. I'm going to actually have, right, raised to the 5 to the third, because I'm able to multiply the two radicands, which is this and that, making it 5 to the third on the third root. And that is where we cancel, because remember, though, if you remember well, let us take a quick look. The third root is the same as 1/3 as an index, right? The third root is 1/3 as an index, right? So again, the third root is 1/3 as an index. So this simply means that what we have is 5 raised to the 3, and then you're going to multiply that by the index, and you could see that becomes 5 alone. So that is the basis on which we are embarking on as we go forward in doing this calculation right there. What we're going to do is to ensure that we multiply the denominator by the same thing here, which is actually going to have us as 3, the third root of 5 square coming on top, right? So then at the end of the day, we're going to have 3, the square root of 5 squared is 25. The cube root of 25 should say all over 5. So there it is. We rationalize that. Let's take a look at an log. All right. 7, whatever I have, say if I have 7 squared there, if I want to actually rationalize this, I'm going to have to take into consideration that this is 7 square, right? So I'm going to have to be mindful of what I use as my radical, so that the 7 square, I need it to turn into a cube, so that the cube root cancels a cube. So basically what I'm going to do here is that I'm going to multiply the numerator and the denominator by the same thing. It's going to be the third root of 7. So I'm going to have to multiply this by the third root of 7. Why am I using 7 only? It's because I've already had 7 square. So when I combine 7 to the 1 and 7 square, I'm going to end up at my denominator with the third root of 7 cube. And then the cube root and 7 cube would cancel to give me the 7 that I need. So let's see, we have 6 cube root of 7 right there. My final analysis is going to be 6, the cube root of 7 all over 7. Why? Because, quick reminder, the cube root of 7 to the third can be written as 7 cube times 1/3. The cube root is 1/3 of a power. So what we could do is this could cancel this. So you could see 7 to the 1 power is just 7, right? So that is what we use, right? So basically, if you're rationalizing cube roots, take into consideration what is your radicand and then find your way out, right? Let's do the final one. And let's say I have 2 root 3. Hold on. Third root of 3 over the third root of, say, maybe 9. Now, at this time, I wanna make sure that I think about what I have. I want to get rid of that 9. So I'm gonna have to raise that to the second power because I have 1 power of 9 here already. So I'm gonna multiply the numerator and the denominator by the third root of 9 squared, the third root of 9 squared. Because when I combine this square with this for the first power, I'm going to end up with the 9 to the third power, which means that the cube root of 9 to the third is going to give me a 9. So on top, what do I have on top? On top, I have a lot of things going on. I have 2, the third root of 3, and that is going to multiply by the third root of 81. So let's take a look. This is going to be 2, the third root of 3, the third root of 81, all over 9, right? This is okay as an answer if I want, or let me put back the third root there, or I could multiply quickly if I want the 3 times the 81. I could multiply the 3 times the 81 and then get a final response right there. All right, so let's put it together. 3 times 81, and that's about 243, I believe. 81 times 3. All right, so it's going to give me third root of 243 all over 9. And as I said to you, this answer is also okay. It depends on who your teacher is or what you're doing at the time. But that would be okay if we want it to be. All right.